Welcome back to Lesson 1, Introduction to Linear Inequalities. Here we'll look at solutions to linear inequalities. Example 1, we're given the inequality t is greater or equal to negative 1.2, and we have to determine which of the following are solutions. So in A, we have negative 2.4. So we'll replace our t with negative 2.4 and then see if the inequality is true. So is negative 2.4 greater or equal to negative 1.2? Well, if you were to graph each number on a number line, negative 2.4 would be further to the left. So it is actually less than negative 1.2. So this is not true. So we can say that negative 2.4 is not a solution. In B, we'll replace t with 1.8. So is 1.8 greater or equal to negative 1.2? Yes, it is. A positive number is always greater than a negative number. So 1.8 is part of the solution. And in C, we'll replace t with 0. Is 0 greater or equal to negative 1.2? Yes, it is. So 0 is also a solution. Now, example 2, we have some solutions that we are going to graph on the number line. So in A, we have A is less than 0.5. So I'll make the note that 0.5 is not part of the solution. And this is because there's no equal sign under the less than sign. So that's important to know because on our number line, we're just going to have a hollow circle around 0.5 because it's not included. Now I'm looking for all of the values that are less than 0.5. So I'm going to shade in this part of the number line. And I'll darken the arrow to show that this continues. Now in B, 6 is part of the solution because there's an equal sign. So what this means in terms of the graph is that we will shade in the circle around 6. Now I want all of the values that are greater than 6. So all these here, shade the arrow. Now in C, we have negative 2 is greater or equal to x. So negative 2 is the biggest of all the x values. So all the x values are going to be less than negative 2. You can rearrange this inequality so that the variable is on the left, but when you rearrange the inequality, you have to switch the sign. So you can write this as x is less than or equal to negative 2 if you like. So make note that the sign switches here. So now to plot x is less than or equal to negative 2, we will shade in the circle at negative 2 and shade in the line to the left of that. Now in example 3, we have to determine which inequality in example 2 each number is a solution for. So we can plug in negative 1 to each inequality to see if the inequality is true, but since we have the graph done, it is much easier to look at the graph to see if it's part of the solution. So in A we have negative 1. So if we go back to example 2, we see that negative 1 is part of the solution for A. For B, negative 1 would be down here, and that is not part of the solution. And then for C, negative 1 is here, which is again not part of the solution. So negative 1 is a solution for A is less than 0.5. Now in B, we have 10. So 10 would be up here somewhere on the number line, and that is not part of the solution for A. In B, 10 would be here, which if we extended the number line, you would see that that would be part of the solution. And in C, 10 is up here somewhere, which again is not part of the solution. So we'll say that 10 is part of the solution for P is greater or equal to 6. Now C, we'll do the same thing for negative 2. Negative 2 would be right here in the number line, which would be included in the solution for A is less than 0.5. Negative 2 would be here in B, so that's not part of the solution. Now in C, negative 2 is included. So it is part of A and C. So negative 2 is a solution for A is less than 0.5 and negative 2 is greater or equal to x.